you into a different way of measuring angles. Most of you are probably familiar with the degree system of measuring angles, and today what we're going to look at is radian measure and how radian measure works. So the learning target for this lesson is to understand what radian measure is and to be able to estimate it using benchmarks and to be able to convert between degrees and radian measure. Okay? So the first thing I thought would be helpful is maybe if we just reviewed circle terminology, because that's mostly what we're going to be talking about when we talk about radian measure. So here we have a circle, and this particular circle is centered about 0. That's a lot larger than I thought the pen was going to come out to be, but that's okay. So here we have our center at 0. And again, a circle is simply defined as a set of points that are equidistant from that center. So everywhere along this circle, the distance from this center point out to the edge of the circle is the same distance. Now, I'm just going to backtrack that big blob there in the middle a little bit, because what I want to start to talk about is specifically, and this is crucial to what we're doing today, is this particular distance in a circle is known as the radius. So we need to know that. The other thing we want to know is, we're familiar with the perimeter of a shape. Well, the total distance around a circle is known as its circumference. And I'm not going to draw that because it would muddy up the whole diagram, but we should be aware that the distance around a circle and my spelling is obviously not the best either, is the circumference. And some of you may or may not be familiar with the idea that the circumference will always come out to be 2 pi r of a circle. And so that's going to become important as well. Some other things we might want to know is that when you travel, any distance along a circle's path, this is known as an arc. That creates an arc, okay? And we can, if we connect what they call terminal arms from the center out to the edges of an arc, we create an angle here. And this variable theta is typically used to represent angles. Because this angle is measured off the center of the circle, this is what's known as a central angle. Okay? And so that'll at least get us started, and we can address any other terms that we need. But we should be, again, familiar with the radius. We should be familiar with the circumference. If we take a portion of the circumference, then we're dealing with an arc. And the angle that is opened up by traveling that arc, if it's measured from the center of the circle, is known as a central angle. Okay? So what we'd like to do then is we'd like to first think about, why are there 360 degrees in a circle? Who decided that there were 360 degrees in a circle? And if you do some digging and some research, that question is actually, I think, unanswered, if I'm not mistaken. But the leading or kind of prevailing theories that people assume is that it was tied to the Earth's cycle around the sun, which is our calendar year. So if you think about it, we now have our calendar year, excluding leap years, down to 365 days a year. It's very close to 360. And so there was this idea that that full cycle was 360, so to travel around a circle, it must be 360 degrees. But what I want you to recognize is that us doing that, us saying that, there's 360 degrees in a circle, is completely arbitrary, and it's almost like overlaying a grid system over this circle itself. It's not physically related to any of the features of the circle. And so what we want to do is we want to move into an angle measure that is related to the physical construction of the circle. I know that's a bit trippy and stuff and might be beyond the scope of whatever you're studying, but we want to move into something that is directly related to the physical features of the circle. And also then what it becomes is a real number. I don't think technically degrees are specifically real numbers. They're real numbers with a unit on them. but now we're talking about actual measured distances as opposed to just decided upon arbitrary systems, which degrees represent. Okay? So, what is a radian? Well, what a radian is, and here's where we're going to get into, relating the physical features of the circle. A radian, if you consider the radius of a circle, so let's call this radius r. If I was to travel an arc that had the distance r, if I was to travel the length of the radius along a circle's circumference, the central angle that I would create, so theta in this case, is 1 radian. Okay? So, you could obviously see the relationship between the name, radian, and the idea of the radius. This is what a radian is. Okay? So when we have traveled the distance of the radius along a circle's circumference, we have created a radian. And I don't have to start here, but we're going to deal mostly with angles in standard position, which means we start at the positive x-axis and we travel in the counterclockwise direction. Okay? That's typically what we call angles in standard position. And so this then brings the idea, okay, if this is 1 radian, right? The next logical question is, how many radians are in a circle? Like, we know there was 360 degrees in a circle, so how many radians are there? So if we say how many radians are in a circle, look at me, I keep trying to spell that wrong. It's probably this nasty head cold. So how many radians are in a circle? Well, if you think about what that question is asking us, it's how many times can we fit a radius in the circumference? And so the number of radians in a circle got it right that time, see? Is going to be equal to however many radians we can fit in the circumference of a circle. So remember from the last slide there that 2 pi r will represent the circumference of any circle. So if we take that, and fitting in is simply division, so I'm going to divide this by r, we can quickly see that these r's will create 1, and we're left with the fact that there are 2 pi radians in every circle. And so that is what enables us. You see up here in our learning target that we're going to be able to estimate the number of radians using benchmarks. This idea, knowing that there are 2 pi radians in every circle, is what allows us to create benchmarks. So for instance, if I haven't opened up anything, if I'm still at my starting point, obviously I could be at 0 radians, right? And I'll tell you another cool thing about radians is that you don't have to write the unit. The way that we write degrees, so if I want to say 0 in degrees, I would say 0 degrees. If I want to say 0 in radians, I just say 0. If I wanted to write 60 degrees, I would write 60 degrees. If I want to write 48 radians, I just write 48. So it's understood that if you're using an angle measure and you don't have a unit on it, that it is in radian mode. Otherwise, you have to place your degree unit symbol, okay? So this would be 0 degrees. If I traveled all the way around, sorry, I think I said degrees there. This would be 0 radians. If I travel all the way around, I'm then at 2 pi radians. So the next easiest benchmark to think about is, well, what if you only traveled halfway? Well, you would have half of 2 pi. So what's half of 2 pi? Well, it's 1 pi. So this is where pi radians is going to be, okay? And then if you think about it, what if you went only a quarter of the way? Well, then you've gone half of this pi. So what's half of pi? Well, it's pi over 2. And then if you want to, you can set up a benchmark for this position, because if you look at it, it's 3 of these pi over 2s. 1, 2, 3. So I've traveled 3 of the pi over 2's. So my benchmark for down here will be 3 pi over 2. Now, you know, a lot of the times you're not necessarily going to be dealing with exact values, the way that we have the exact values listed here. So what you do need to recognize is that in this instance, you can approximate each of these positions by simply letting pi be 3.14. So for example, I'll just mark this in a different color. This would be equivalent, or not, I shouldn't say equivalent, but this would be approximately 3.14 radians. Okay? If I was to cut this in half, I think it's 1.47, right? If I'm not mistaken. 1.47. My brain's not feeling that great today, so I'm just double checking that in my calculator here. 3.14 divided by 7. Sorry, divided by 2 is 1.57, and that's why we check things when we have head colds. All right? So I'll dig in and get my little eraser here. And yeah, that one should have been apparent, right? By now you've clicked off the video and moved somewhere else. That's okay. I'm all right. I still sleep good. Okay, so we're going to say 1.57. Then this would get us to 3.14. We would want to add a 1.57 to this 3.14 to get to this next position. So let's see if we can do this one correctly. We're going to get a 4, obviously. This will get us up to 6. And these will make another 11 hundredths. So this will end up being 4.71 in terms of an approximation. And then two 3.14s would be approximately 6.28. And 0 is 0. So you can use these benchmarks to estimate where particular numbers of radians land. Okay, so for example, if I told you, oh, I've got 5 radians. And again, I don't have to write that unit. I could simply say I have 5 radians. Well, you know that it's in here somewhere, and you know that it's probably closer to the 4.71 side than you do the 6.28 side. So that's kind of where we want to go. You could also have someone say, hey, I've got pi over 6 radians. Where's that at? Well, you know that pi over 6 is bigger than 0 and smaller than pi over 2. So pi over 6 is probably in here. And you can also say, hey, look, here's pi. What would happen if I cut that into 6, right? If I tried to break this up into 6 equal pieces, I'd probably be somewhere around here. Okay? So another part of this learning target is to be able to convert between degrees and radian measure. And so in order to do that, we need to kind of formulate a scale factor or some sort of a ratio between the two. And we've already kind of come up with that if you think about it, because we know that there's 2 pi radians in every circle, and we also know that there are 360 degrees in every circle. So if we take that proportion and we just divide both sides by 2, we end up getting pi is 180 degrees. So pi radians is 180 degrees. What that'll enable us to do is to formulate a conversion factor, and we're either going to use pi over 180, or we're going to use 180 over pi, depending on what we're trying to accomplish. And I think that's probably best shown using an example. So hopefully you're okay with this idea. We're using the fact that there were 2 pi radians in every circle and 360 degrees in every circle. We've simplified that ratio into pi to 180. And conversion factors are always made by taking both sides of the proportion and expressing them as a fraction, and then using them to multiply other measurements by in order to convert them to the unit that you want. Okay. Now, in typical, what you do, and let's again look at an example. So here we want to convert from degrees to radians. So I want to get rid of degrees and I want to end up with radians. All right. So if I take my 90 degrees, I want to get rid of this unit. Now, I know I'm going to multiply by either pi over 180 degrees or 180 degrees over pi. If I want to get rid of degrees, I need to have my degree measurement in the denominator of this fraction. So that's what identifies to me that I'm going to multiply by pi, and notice I don't put a unit here because it's understood it's radians. So I'm going to multiply by pi over 180. Now, what that's going to give us is after those units, and this is about the only time you'll hear me say cancel, other than if you're creating 0, but these units will cancel, and you'll be left with 90 pi over 180. And 90 over 180 is very easy to simplify. So we know that that's 1/2. So I'm just going to mark this as pi over 2. And again, if we just go back and look at the circle, you would know where 90 degrees is. You know that 90 degrees is right here. And so it makes a lot of sense that, hey, look, 90 degrees end up being pi over 2. If I tried to convert 180, which I don't even have to because that's at the core of our ratio, we know that this would come out to be 180 degrees. If we did it to 270, we know we would get 3 pi over 2. And if we did it to 360 degrees, we know we would get 2 pi. Okay? So that's the idea behind these benchmarks, is that you would become familiar with the position of those kind of special angles, all right? So back to this though, I could approximate this if I wanted to and let this be 3.14 and divide by 2 and get an approximation of that 1.57. So if you wanted to, you could list that as 1.57, but truthfully, you're better off getting used to exact values if you can get them, all right? So let's take a number that's not as nice. Let's take negative 127, all right? And yes, you can do this to negative angles. I'm going to apply the exact same strategy. I want to get rid of my degrees, so I'm going to put 180 degrees in the denominator, and I'm going to put pi radians up top. Now, I don't know if 127, how prime it is or what factors it has. And truthfully, I'm not that interested in trying to fight my way through this particular simplification. So what I'm going to do is approximate this whole value. I'm going to get it to come out as a decimal. So what I'd like to show you is how you end up doing that. Now, I'm going to use Desmos, their online graphing calculator, to do this. And so I just want to show you what I'm putting in. All right, I'm putting in negative 127. And then I'm putting in pi, you just type pi, divided by, and then it's 180 as our conversion factor. You'll notice that I didn't put the units in because those units are going to cancel out anyway. And here you can see that if I was to round this to 2 decimal places, we're getting negative 2.22, okay? So that's how I would approximate that value, negative 2.22, and I don't have to write a unit because this is radians, all right? What if we took an angle that was larger than a full rotation, like 435? Well, we can still do the exact same thing, okay? So we take our 435, and then we're multiplying by pi over 180 degrees. And in this case, again, I'm probably just going to go with the approximation. Although I know these will simplify if I wanted to do that. You can see that they're definitely both divisible by 5 at least. So if you wanted to go through that process, you could. In the interest of time, I'm just going to say this is 435. Actually, I'll show you something cool about Desmos while we're here. You can literally, if you already have that conversion factor set up and you're doing a bunch of these, just remove your front angle, put 435 in, and there's your value. 7.59 will approximate this at. So if I was to say anything, I'd say this is 7.59 radians. Okay? So let's go the other way. Let's go from radians to degrees. Now, I think I slipped my calculator behind here, so I'll have to see if I can dig that back up somehow. It's on my Chrome tab. Sorry, it should be right behind here. There we go. So let's do the opposite, all right? Now, pardon my software here because it wouldn't allow me to put in the pi symbol, so I just wrote pi divided by 4. But what I was going after here is I want you to convert pi over 4, I want you to convert 7, and I want you to convert negative 3 pi over 2. And there's an important thing to take away from this. People get in the habit of associating that it's only radian measure if pi shows up, and that's not true. All right, 7 can be 7 radians, right? Anything can be in radians, all right? So don't get hinged on the fact that if pi shows up, it's radians, or if pi shows up, it has, like, I could tell you that there's pi degrees. Like, that's a degree angle, right? So what you're looking for, what gives away whether it's in radian or degree, is that notation, is that unit right there, all right? So let's get into converting these. Now, I have to know in my head that these are in radians. And sometimes you'll see people write rads or radian after it. But what that tells me is that, again, I want to get rid of radians and end up with degrees. So it tells me that my radian measure, which was pi rads, has to go on the bottom. And the 180 will then go on top. And so if we look at what happens here, these rads will cancel. Again, I very rarely say that. And the pi over pi will create a 1. And what that's going to leave us with is 180 degrees divided by 4. Well, if you cut 180 degrees into quarters, you'll end up with 45 degrees. Okay? Taking the 7, we're going to do the same thing. We're going to multiply by 180 degrees over pi rads. And so here we're not going to get any of that 1 generation because there is no pi. So I'm going to go right into that calculator and I'm going to try that calculation. All right. So we're taking 7. I'm multiplying by the 180 and I'm dividing that by pi. And you can see that the answer I get is 401.07. So approximating this, I get 401.07 degrees, right? And does it make sense that this is a little bigger than 360? Sure it does, because we know that 6.28 was approximately a full rotation. So this got to be a little bit bigger than that, right? Now, if we look at negative 3 pi over 2, we're going to do the same thing as before. Negative 3 pi over 2. We're going to multiply by 180 degrees over pi, and I'm not going to write that unit in this time just to get you used to seeing it as just written as pi, right? So our pi's will create 1, and what we'll be left with, if you think about it, is negative 3 over 2 times 180 degrees. Well, the easiest way to handle this is to cut the 180 in half first. That would make it 90. And then you have negative 3 90s, which is going to give you a negative 270 degrees. And so there you have how we convert from degrees to radian measure. Now, the other piece of the learning target was about estimating angles. So I thought what we would do is maybe pick 2 angles, and let's just try and estimate these in both degree and radian measure. So let's say we've got one central angle, and let's take it into the 3rd quadrant. Let's say I'm trying to measure this particular angle. And let's put another one in the 2nd quadrant. Let's try and measure this angle. Okay? So if I was to ask you in terms of degrees what you thought these might be, a lot of you would use the benchmark. You would say, okay, I know this is 0 degrees. I know this is 90 degrees. I know this is 180 degrees. I know this is 270 degrees. And so you might come up with an estimate that says, look, I know I got to go past 180, and I know I'm shorter than 270. So just on a whim, I might call this, I don't know, 210 degrees or something like that. Okay? So that could be a perfectly viable estimate. Now, what if you want to go and do that in radian mode? What if you want this in radian? Well, I know this is 0 radian. I know I can think of this as either pi over 2, or I can think of it as 1.57 radians. I know that this is pi radians or 3.14 radians approximately, right? I know that this is 3 pi over 2 radians, or I can think of it as 4.71 radians approximately. So you could look at this and say, all right, I need something that's between 3 pi over 2 and pi. Or probably most of you would look at it and say, okay, if that's 3.14 and this is 4.7, I don't know, this might be like 3.5 radians or something like that, right? So you could literally say something like 3.5. Again, we're just estimating here. We're just playing around. But I just want to show you how you can use the benchmarks to try and to get an idea where things are at, right? Now, if you're going to do this through fractions, you might have to think that this is 2 pi over 2. And this is 3 pi over 2, and then you got to start thinking, okay, what's in between 2 pi over 2 and 3 pi over 2? Well, it's a 2.5 pi over 2. And, you know, you can't list 2.5 pi over 2 because your numerator being a decimal is improper or unconventional, I should say. So what you'd want to do is double that and call it 5 pi over 4 maybe, or something like that. Okay? So that can give you an estimate. Now, let's do the same thing with this one. So I know this is 90 degrees. I know this is 180. I'm just going to take a guess and say that this is 100 degrees. When I go to do radians, I know this is pi over 2, and I know that this is just pi. So the trouble is, this coefficient in the numerator is 1. And so it's really difficult to think of this in terms of fractions. So what I'm more inclined to do in this case is, if this is 3.14 and this is 1.57, I'm really not that far beyond this. So I might call this something like 1.8. And that's as simple as it has to be. So hopefully in this lesson, like I said, you learned what a radian is, number one. It becomes more important as you get further into things like proofs and calculus and stuff like that. But for this lesson, hopefully you know what it is, where it came from. Hopefully you're able to convert between radian and degrees, and hopefully you feel at least a little bit comfortable estimating angles using the benchmarks that we've set up. Thanks for watching.